Assalamualaikum and good day. Welcome back to my BCN 2193 Network Technology. Okay, our second topic, 14.2 Packet Forwarding. This is how a router forward a packet. You can look for a diagram. Number 1, a data link frame arrives at the router in the ingress interface. So the router will be examine the destination IP address inside the packet header. You know how to get the packet header? The router will decapsulate the frame. Remove the data link header and data link trailer, then we have a packet. So we take a look at the destination IP address. So when we have the destination IP address, we will look or try to match with the routing table. So the router will look for the longest matching prefix in the routing table. So if there is a match, so for number 3, we go to number 4. The router will encapsulate the packet in a new data link frame. You can see here, data link frame here might be, of course, it cannot be same. But they can be the same type, but their data must be different. Okay, because they are going to send into a different network. Data link are only operate at the local area network, at one network. So they cannot move into another network. In order to go to another network, they must build up a new data link. So in here, the router will encapsulate into a new data link, which matches the network protocol. The router will forward out the egress interface either directly to the host or device that with the IP address or into another router which is connected into that device, or connected into another router and another router that into another one. But if there is no mesh and there is no default route inside the routing table, so the router will drop that. Of course, if we configure with the default route, no matching will be forward into default route. Okay, this is explanation about how they do directly. So whenever they found their path, it must be forward through the directly connected network. So that network can be Ethernet, or it can be a serial or whatsoever. So they must be encapsulated into their format. So for the Ethernet, must be Ethernet frame. So they will use a destination, they will use the MAC address. But for serial, they use HDLC or one-to-one connection, which is doesn't need an addressing. Okay, or the router will forward the packet to the next hoop router, which means this is a remote network. So the next hoop router will then re-forward the data to the respective interface or destination. And if there is no mesh, the router will drop that packet. So it will be removed from our network. Okay, for end-to-end packet forwarding. So we are going to take a look for a data link layer. Okay, for end-to-end packet forwarding. So the time for a connection between router, we use a serial link, which can be a point-to-point protocol or HDLC protocol or any layer 2 protocol that we have. They do not use or they do not need for addressing because they are one-to-one. So of course, one send, the other one will be received. So they will encapsulate with their appropriate data link frame, but not using the Ethernet frame. Ethernet frame, we have the destination MAC address and source MAC address. So the primary responsibility of the packet forwarding function actually to encapsulate packet in the appropriate data link frame type for the outgoing interface. So as I said earlier, the data link is effectively for one network only. So when the router receives from the ingress, actually there's from one network, and then they're going to forward out, it will be the another network. So it will be encapsulated with their data link format. The more efficiently a router can perform this task, the faster packet can be forwarded by the router. So how the router can determine their path efficiently? So there are several packet forwarding mechanisms that we have. First, we have a process switching. Second, we have a fast switching. Third, we have Cisco Express forwarding. So let's take a look one by one. Okay, for a process switching, this is an older packet forwarding mechanism but still available in the Cisco router. Why is it available? Because we still need to use this process switching, at least for first entry. Okay, when a packet arrives on the interface, it will be forwarded into control plane where the CPU match the destination address in the entry of the routing table. So in order to determine the exit interface and forward the packet. But what happened with this mechanism actually, for every packet, the router will go through this process. But if you can imagine, for a flow of data, it usually coming from one device and forwarded into one device. Let's say you are downloading a file. So, one server must send in a flow or stream of data to you. So, it can be like 10 or 100 of packet. It must be from the same source and same destination. But the router will do the process switching for every single packet. So it's gonna take a lot of time. So for first packet, okay, it will be sent, it received from PCA, sent to PCB. And then for the second packet, PCA to PCB. Take a look inside the routing table again. And the third packet from PCA to PCB. Take a look in the routing table again in order to determine the exit interface or egress interface. Quite slower compared to other mechanisms. So, our next mechanism is a fast switching. By the name itself, forward the data more faster compared to process switching. Okay, fast switching actually a successor to process switching but still using process switching. So, that's why we still have a process switching inside our router. So, it uses a fast switching cache to store network information, but before they can build out a cache, take a look. I use the same example. We have a flow of 100 packets that coming from the same source and should be forwarded to the same destination. So the first, the router, when they receive, they take a look inside the routing table. So they will use the process switching in order to determine which path, which exit interface. And then they put inside the switching cache, fast switching cache. So for the next packet, when they receive from this destination, from source A and destination B, straight away they found a match inside the fast switching cache. So it will be forward out into the entry that they found inside the fast switching cache. So it will be more faster compared to fast switching. So when there is a packet where it doesn't have a match inside a fast switching cache, and then it will go to the process switching. So that's how they do build up on the fast switching cache. Okay, lastly is a Cisco Express forwarding. This is what we use in most of our recent router that we have. Okay, and this is a default Cisco IOS packet forwarding mechanism. Okay, Cisco Express forwarding build a forwarding information base, just like a fast switching cache. So there is a table. So with the agency table, so for this source and that destination must go through this interface and so on. So it's not packet trigger anymore, just like a fast switching. It's not a packet trigger like fast switching, but it's a change trigger. CEF have a forwarding information base for all known source and destination inside their table. So they doesn't need to look inside the IP table. So they only need to change when there is a network topology change. So which means there is a new data and so on. So most of the time, when the network is converged, the FIB head and adjacent table contain all information that the router would have to consider when they need to forward a packet. So it's more faster compared to fast switching and process switching.